Hi, welcome to Unit 19, which is a sort of hodgepodge of different things getting you ready to do statistics. So we're going to put data into a Venn diagram and into something called a two-way frequency table. So please answer the first question. It's literally counting. Had a curfew, but no chores. So we're looking for yes for curfew, no for chores. Yes for curfew and no for chores. So that's Frank and Lacey, or 2 students. How many students had neither a curfew nor chores? So that would be no for both. Karen had no for both. Steve had no for both. Bob had no for both. I think that's it. And so there are 3 students who had no chores and no curfew. We're going to put data like that into something like this. This is called a Venn diagram. A Venn diagram always has a rectangle, okay? And in the bottom corner is going to go the number for how many people had neither item. Where the 2 circles overlap is both. On one side of that, you'll have the people who have chores, yes for chores, but no for curfew. And on the other side, you'll have the people who have a curfew, but no chores. So it's a way of sorting data. So this is the same thing we saw in the warm-up. And this is a Venn, we're going to make a Venn diagram of this bivariate data. So what is bivariate? Well, bi means 2, as in bicycle, and variate means variable. So it's got 2 variables. What are the 2 variables? Chores and curfew. Okay. So let's draw a Venn diagram. So you start with a rectangle, and then you're going to need 2 overlapping circles. And we'll call the one on the left chores, and the white one on the right curfew. You could switch them. And I like to start with the no's, all right? So who had no chores or curfew? So 2 no's, Karen, Steve, and Bob. So there's 3 people who had neither. The neither chores no curfew. That always goes there. Now, so let's look at who had both chores and a curfew. Well, Jane had chores and a curfew, and Sharon. So there were 2 people who had both. That goes in the overlapping part. Then the people who had chores, yes for chores, but no curfew. So yes for chores, 1, and no for curfew, 2, 3. We had 3 people who had chores, but not a curfew. And last but not least, we had 1, 2 people who had a curfew, but no chores. And that's a Venn diagram of bivariate data. So let's do one for soccer and basketball. All right, some people play both, some only play one. Try it on your own. Pause. So I have 2 for neither plays basketball nor soccer. Do I only have 1 for both? I think so. Yes for soccer, but no for basketball. 1, 2, 3. And, oh no, 4. There's the 4th one. Yes for soccer, no for basketball. So let me erase. And then 1, 2, 3 for basketball, but not soccer. And so another way of sorting the same data is called a two-way frequency table. So you're going to have to copy this that you see here. That's a two-way frequency table. And it sorts the data in a different way. So here's the Venn diagram, right? This is the Venn diagram that we just made. And so, right, who had So 2 people played no soccer and no basketball. So that 2 goes right there. Fill in the rest. So there was 1 person who was yes for soccer and yes for basketball. That 1 goes there. Then we have 4 people that yes for soccer, no for basketball. And we have 3 people who are yes for basketball and no for soccer. So same data using a different sorting technique, a two-way frequency table. And right, it's bivariate, it's two-way because you can read it across and you can read it down. Those are the 2 ways. Right, so let's do this one. So copy this and fill it in. So we have 2 for no curfew, no chores. We have 3 that have both chores and curfew. We have 3 that have chores but no curfew, and 2 that have curfew but no chores. Right, so now you're going to go straight from the data. So I only see 1 with a no for both. I see 2 with a yes for both owning a dog and a cat. Three that have a dog but no cat. That was there. And then 1, 2, 3, 4 have a cat but no dog. And so you use these tables to answer questions like you just see here. So there was a bunch of candies. Some were chocolate, some were not. Some had a cherry inside, some did not. So it says, what fraction of the people that got cherries? All right, so you're going to make a fraction. And on the bottom, I want you to put the total amount of people who got cherries. Write that now. Well, 11 people got cherries in chocolate candies. 3 got cherries in non-chocolate candies for a total of 14, right? You just add those up, you get 14. So there's 14 total people who got cherries. What fraction of the people that got cherries did not have chocolate candies? Right, so not chocolate. Well, that's 3. So the fraction is 3/14. 3 out of the 14 people did not get that got a cherry did not have a chocolate candy. So answer the next question. So what fraction of people that got chocolate candy? That's this group. So we add it this way, and hopefully you add those up and you get 16. So the denominator of the total this way is 16. So this is the two-way. The first one we did down, we were looking at the total amount of people who had cherries. Now we're looking at the total amount of people who had chocolates. What fraction of the people that got chocolate candies had no cherry? Well, 5, right? Not cherry. Right, so 5 out of the 16, or 5/16 of the chocolate candies had no cherry. So answer the question, what fraction of the sports cars had accidents? So there were sports cars and not sports cars, and some had accidents and some did not. Right? You might have a theory as that people who buy sports cars get in more accidents. So this is how you would test that theory. So fraction of the sports cars. So 6 people had accidents, 26 did not, for a total of 32 sports cars, right? So we're going across. That's the total amount of sports cars. What fraction of them had accidents? Well, 6 out of the 32. Now, hopefully you look at that and there's something wrong with that. What is it? You have to simplify your fraction always. And so 3/16 of, it was 6 out of 32, but you simplify to 3/16 of the sports cars had an accident. So most people who bought a sports car did not have an accident, but 3 out of every 16 did. What fraction of the accidents were by sports cars, right? Sort of seems like the same question, but it's not. What fraction of the accidents? So we need the total for accidents. When you add down, right? There was 21 accidents. 6 were by sports cars, 15 by not sports cars. So 6 out of 21 were by sports cars. Something's still wrong with that. So 2/7 of the accidents were by sports cars. So most accidents don't involve a sports car, right? 2 out of the 7 did. All right, so that's the lesson. Let's practice. So we're going to make a Venn diagram. No, we're not. We're going to make a two-way frequency table. All right, so this time you have to do it all by yourself. So here you go. All right, and so then we have, so let's do dog, no dog. Then we have cat, no cat. So 23 people had neither. 6 people had both. 12 people had a dog, but no cat. 9 people had a cat, but no dog. Okay. Oops, there it is. Let me erase to make it neater. Didn't realize I had done that. So let's fix that. While I do, you can start the next one. What fraction of the cat owners had a dog? There were 15 total cat owners, and 6 of those 15 had a dog. Or 2/5 of the cat owners had a dog. So most cat owners don't own a dog. 3 out of 5 don't own a dog. It works that way. What fraction of the dog owners did not own a cat? Right. We'll add across. There are 18 total dog owners, and 12 of those 18 did not own a cat. Simplifying our, oh no, it's 6. And so 2/3 of the dog owners did not own a cat. What fraction of the people that didn't own a dog? So here's all the people that didn't own a dog. So that looks like 32 people didn't own a dog. How many of those owned a cat? 9. And, oh, you can't simplify that. It's done. It's 9/32.